Switching on a light is something most of us never really think about. We expect heat, we expect power, we expect energy to simply be there whenever we need it. But behind that simple switch lies a growing global problem. Rising energy costs, increasing pressure on national grids, dependence on fossil fuels, and a growing question about how we power our homes, businesses, schools, and hospitals in the future. Renewable technologies such as solar, wind, and hydro have helped move the conversation forward, but they also raise another important question. What happens when the grid fails? Today I've travelled to Italy to meet a man who believes he may have part of the answer. Italian engineer Dr. Marco Bertelli has spent years developing advanced boiler cogeneration systems designed to rethink how energy can be produced and used. His work recently received recognition at the prestigious International Lafonti Awards, which honours excellence in innovation, leadership, and technological achievement. Today we're going inside his workshop to discover the thinking, the engineering, the vision behind this remarkable technology.
I am Marco Bertelli. I am a civil engineer. I have experience in construction because I worked as a manager in companies producing reinforced concrete products. But my hobby, which then became my real profession, is hydrogen. It began in 2006, when I left a work experience in France, in Gravelines, at a nuclear power plant. For about a year and a half, I worked there as the safety manager. I understood that nuclear power plants have a large dispersion of oxygen and hydrogen due to the cooling of the central core of the nuclear plants, where water goes down at 1710 degrees, so it separates. The molecule is broken, and we have hydrogen and oxygen. This hydrogen and oxygen is released into the atmosphere, so it is energy that we lose and could recover. From there, I was inspired to do something, a machine for domestic use, to give some help to the world, so to speak. Hydrogen is still a product to be discovered. It is a product that leaves dark areas, and this makes people doubt its functionality. But let us not be mistaken. The world, 80% of the world, is hydrogen. We live today because hydrogen exists. The sun burns hydrogen, and in its combustion generates helium. Why is there no oxygen? This is important, because if there were oxygen, it would no longer generate helium. It would regenerate energy. And so what we do in our cell is precisely this. We generate energy by breaking the isotopes of hydrogen. By putting oxygen there, it does not create helium, but recreates thermal energy. So in a certain sense, we are reproducing the reaction that already happens in the sun, limiting it to a very modest use because in the sun there are millions of degrees, while here there are only a few hundred. The most difficult moments were finding the economic resources to continue. Then also the products, because not everyone is able to make this type of machine. I began, then I received financing. I hired employees. I trained them, informed them, supervised them, and we started to make it. When we make an innovative product, a product that does not exist, people use skepticism as a weapon of retaliation, saying and always crediting things that are not later confirmed, because they say bad things about the researcher, saying he wants to speculate. So there is a deep envy that annihilates the system. This is something I noticed does not happen in Anglo-Saxon countries and in American countries. On the contrary, if you are a researcher, someone who brings innovation, that is well accepted, because even if the innovation is minimal or might not be efficient, still someone has created something for others. The industry produces what the market requires, because it has no other alternatives. Certainly, it does not benefit our environment, because with a boiler, even if I use a condensing boiler, I burn methane. I produce fine particles. Fine particles create respiratory discomfort, both for elderly people and also for children. So there has been a large increase in respiratory illnesses for precisely this reason, because fine particles have a decisive and important impact on people's health. Installing these machines means that I use hydrogen and oxygen. In turn, I obtain steam and automatically obtain water. So I do not pollute, because I could reuse this water again and extract hydrogen from it another time to make energy again. So it is clean energy, green energy. The problem is that by entering this market, we step on the toes of the large industries, both in the methane sector, therefore boilers, and also in the electrical sector, because our machine also produces electricity. Now, these new machines are no longer like the previous ones that worked in island mode, completely in island mode. These can also work connected to the grid, so the excess energy they produce can also be transferred to the grid. So we no longer have a competitor that obstructs us, but we could have a competitor that could stand alongside us. The industry serves the machines that the market requires. To do this, the industry would need to take responsibility. Investors would need to take responsibility for this project and develop it. It could be brought to a much more optimal situation. Because let us say, this is a project as if it were a newborn child, and it should be brought to adulthood, and therefore behind it there is all the development, a technology that we could also use for batteries, also for hydrogen recovery, both with ammonia and with caustic soda. Hydrogen can be recovered in many ways. It can also be recovered with solar. In short, there are various aspects to do what? To make electricity and hot water. Hot water also allows us to provide cooling, because if we install a lithium bromide chiller, automatically from heat we obtain cold. Certainly there are costs. Everything has costs. But we have no pollution, no fine particles. We have a cleaner world. The development over the next 10-20 years is simply finding a partner anywhere in the world who comes and takes responsibility for the plants, putting it into production and optimizing the product. And putting it on the market, that is all. It is bigger because people do not see the benefits of this machine. Then there is the unknown, both the economic unknown and the product unknown. So people find it difficult to change path. They always remain on the main road, the one they have always traveled, and so changing becomes difficult. This machine can change the system of homes by installing them and having a fairly important saving both in heating and in electricity, and then also having the possibility of cooling. So it is a machine that is good both for a cold country and for a hot country. If it is put on the market, the machine will be requested. It will be requested. So there is an important exposure. It is enough to make the machines and start installing them, and demand will be exponential. Many companies also try to copy it. They have not yet understood the product. They have not yet understood how it works. But once it is put on the market, it is a machine that has no rivals. It is an exclusive product, so it really affects all the producers of this product. Therefore, it creates enemies because it is a unique product in its system. It can give you electricity, it can give you heating, it can give you cooling. The costs are very contained because it works on the molecular decomposition of water to obtain hydrogen. And at the same time, if I have surplus energy, I can sell it. I also have the possibility of using photovoltaic power. I also have the possibility of using wind power connected to the machine. This is an exclusively private system. That is, for people, for homes. It is not a machine for industry. Industry needs large quantities of energy. We are talking about hundreds or thousands of kilowatt-hours. These machines can reach 5, 6 kilowatts, and the American one can reach 12, by changing the alternator, changing the electric generator. For industry, you need another type of machine. We have another machine. There is a patent for an industrial machine. There it starts from 300, 400 kilowatts. There we obtain hydrogen with photovoltaic power. Once the hydrogen has been obtained, we combust it inside a system with a reactor that produces about 2,600, 2,700 degrees, all in tungsten. The water outside reaches up to 600 degrees, producing about 200 bar of steam. With 200 bar, you can run turbines, you can run everything. And so with those turbines you make electricity and also heating. But you need fairly important areas and dimensions. Conventional ones. It is all a benefit that comes to humanity.
We're here at the workshop to see how this product works, and Marco Batelli, the chief engineer, and Alec Delan, the technical director, are going to explain to us in some detail how this project works.
Here we have the new prototype of the machine, which we are producing, the second version after we already made the first one last year working to 5 kilowatts. And this is a machine that will work more or less to 10 kilowatts. We have the frontier of the machine, of this new prototype which we are building, which we're going to be a lot pretty when it goes to industrial production, of course. And we have here a very nice 10 kilowatts batteries unit. Is going to be here all the head of the software of the machine, which we are still developing. But here we already close up to the mechanical version, which is possible to switch on very soon and demonstrate that our EP is going to be done and working already. Then after that, we're going to put it to the next level, which is going to be the software and intelligence. Here we have the new explosion chamber, which is something very nice and delicate, which is going to contain 7,000 degrees of heating in the electrical arch, where is going to be basically the reaction, which is going to be a thermodynamical reaction, where we're going to open up the isotopes of the water, which is in the deposit. Is going to be in a better deposit, but it's a deposit up there. Is basically a 3-liter deposit, 5-liter deposit, something like this, which is going to be worth maybe for 1 week operational of this machine. So we think we can use something like half liter of water maximum per day to create 10 kilowatts of permanent electricity, plus around 500 kilocalories, 500,000 kilocalorie hour to distribute in central heating or hot water or domestic water. So here we have our chamber, which has an interscambiator, heating interscambiator basically. When it's on, it's going to activate also a turbine alternator. So the steam is going to activate all these pieces, and from there we're going to produce the electrical part, which with the plug, basically here there is the heat. The steam will come out on this place where this is the head of our machine, which is going to connect after with the software and say when to switch on or off all the pipes that we have here, which is thermodynamical valves, okay, which now is manual, as you can see, but after it's going to be all electrical valve, of course, which they're going to be automatized from the software. From this, we distribute in 2 ways. One is to create the electricity power, okay, through, if we want to go on the other side, I show you another component here, which is part of our EP, which is another new turbine, okay, which is going to get to 10 kilowatts more or less. Now, this is a double turbine, okay, which is in our patent. Then from here, the last piece we have here is going to be mounted up here, is an alternator of electricity, which is going to produce the electricity and distribute to through, of course, the plug here, to plug in our electrical whatever counter you have, okay? So from there is another circuit that goes through here, and then yes, because from here we recover the steam, the heat, hot water, and we push it in this, which is a heat interscambiator, okay? From this we have 2 closed system. One goes back to the chamber and will carry on heating the circuit, okay, recharging basically of thermodynamic. And another one is weighing out, our way in of central heating or whatever we need to distribute our hot. So we want to warm up the swimming pool, we have radiator, we have underfloor heating, whatever we want, we distribute. And then we'll come back and again, in a closed system, recover his thermodynamical, whatever we need. This can be also called at a certain point where we already have our unit of thermodynamic cold, which is going to be added to this. So we're going to create power and thermodynamic in hot and cold to distribute in the house in different ways.
Today the world stands at an energy crossroads. What I've seen here in Italy is not just engineering innovation, but the vision of one man determined to challenge the way we think about heat, power and energy independence for the future.